When you set up a Kanban system, you have a choice of how many Kanbans you want to drop in the loop. A favorite answer to, well, how many should that be, is the Kanban formula, which you can see printed here. Now, the secret to using this formula is being able to roll up all of these input parameters. Let's look. Dumfries Fabrication cuts sheets of steel into small square blanks used by other work centers. Okay. Since steel blanks are used continuously, Dumfries Fabrication has decided to create a Kanban loop to control the item. Okay, so we're setting up a Kanban loop. Blanks are transported in metal baskets that hold 40 blanks each. Ooh, ooh, ooh. I need that. C equals container size. They just mentioned the container size. We need to know the size of the containers that will be circulating in the system. Found it. All right, what else? Dumfries Fabrication will add bright orange detachable tags to the baskets to act as Kanbans. Okay, so bright orange tags are the same thing as Kanbans. That's what they're going to be using for Kanbans in this scenario. What is not certain, however, is how many bright orange tags should be circulating in the loop between the welding shop and the basket storage area. Yes, that must be why on this note frame that formula has been snuck in there, but we're still missing a bunch of stuff. Okay. The combined use of steel blanks throughout Dumfries Fabrication averages 160 per 8-hour day. Ooh, I need that also. Because that's demand, the demand rate. And that's exactly what they're talking about. These steel blanks, what's the need for them? What's the use for, how much is used? And there's a rate, 160, so I'm going to write that down. 160 per 8-hour day. Okay, good. Then I've got that part. Dumfries Fabrication would prefer a 10% safety factor. Aha, that's that right there. It's policy. Policy variable. They said 10%. That is very often how it's spoken of. We just need to remember that for the purpose of filling out this simple formula, we want to state it 0.1. We want to state it as a decimal place. No problem. The welding shop needs 7 hours to fill one metal basket. Let me put that here. That is L. That is because we're familiar with this concept of lead time, the delay between a signal that we need some and when we can actually have it. And what they're saying is if they were signaled that they needed to fill a basket, it would take them 7 hours. So that's actually L. All right, D, L, X, and C, we have everything that we need. Just fill in the formula to determine the number of bright orange tags that should be circulating in the loop. The bright orange tags are the Kanbans. So you're probably thinking, okay, fine, yes, I'm going to write 160 times 7 times 1 point. Okay, yeah, yes, except don't write that. Don't write that, especially not in ink, like I'm using. Don't write the 160. This is pretty simple, this formula. There's only one thing here now that we just need to be very aware of, and it's right in here. D and L. That's why I'm kind of putting brackets around them. To get this formula to work, to get a rational answer out of it, D and L need to be speaking of the same time interval. That's why I said don't write 160 yet, because D equals 160 was per 8-hour day. L equals 7 was just plain old hours. We need to adjust either D or L so they're both talking about the same interval of time. We could adjust L to be, we have to say like, okay, 7 hours is how many 8-hour days? That's kind of like, we could do that. That's not very intuitive. The easiest thing to do in this particular scenario is we just have to make a small adjustment to D. Okay, L's in hours. Let's make D an hourly rate. That's what we're looking for. Okay, it is 160 per 8 hours, but I want it to be an hourly rate. So I just say 160 divided by 8. This is just logic. Is revealing that, oh, that means that they're using up these steel blanks at a rate of 20 an hour. Perfect. That's the number that I need for filling out the formula, because that one matches L, so to speak. Oh, all right. So anyway, fine. What is the result? Let's see. D, 20 per hour times L, 7 hours, times 1 plus 0.1, right? Divided by C is just the container size. Okay. I get 3.85. 3.85 Kanbans or bright orange tags. That's the result of the formula. That's not going to be a very helpful suggestion to Dumfries Fabrication, because there isn't any such thing as 0.85 bright orange tags. The actual answer, if you will, from Dumfries Fabrication standpoint is, well, 3 or 4 bright orange tags. Which is just here, another name for Kanbans. That is essentially our recommendation. Now you may be looking at that and saying, well, wait a minute. How come we didn't, why are you saying 3 or 4? I mean, how come we didn't round and just say, why is the recommendation not definitively 4? With the Kanban formula, another feature of it, it's a simple formula, but another feature of it is if you don't get an exact integer answer, there isn't any strict rule to rounding up or rounding down. This recommendation, we could have additional advice that we gave Dumfries Fabrication with it. They can try 3 bright orange tags in the loop. They're not going to be getting a full 10% safety factor. Do you remember the safety factor? Yeah, 3 orange tags is not going to meet the 10% safety factor, but I don't know, it might work. They could try that, or they could try 4. 4 will exceed the 10% safety factor. 4 will provide a somewhat higher safety factor than that, but the implication is that 4 orange tags in the loop will pad their inventory out a little bit more than what they had stated was desirable. Okay, but they're going to have to make a choice either way, 3 or 4.